Hi everyone, and welcome. This is Professor Thayer with you here to talk to you about looping. So we are continuing on our discussion of flow control, and there are many different kinds of looping that we can do. So we've already done the if blocks, talked about a variety of different ways you can use if statements in their various if blocks in order to change how the program is going to flow through that program. Now, looping is another way that you can do this, and we'll talk about several different kinds of looping, but we will start off today with the while loops. We'll actually be on this for this week, and we will discuss the for loops next week, which is a different variety of loops. But within the category of the while loops, there's a couple of different ways that they can be set up. And so over the course of the week, we will have a look at that. So let me go ahead and share my screen. And as always, you're welcome to follow along in whatever way suits you best. So I'm going to do this. And so as I was saying, we're going to be talking about the various kinds of while loops. We will today cover the accumulators and augmented assignment, which isn't specifically about the loops, but these are things that you need to understand in order to do the loops. And then we will visit the simple while loops, and we will see some of the other flavors of the loops throughout the week. All right, so let's start off with accumulators and augmented assignment. So what is an accumulator? You may be familiar with the term accumulation just in general use, like, for example, accumulation of wealth over time. So you get this idea of something is growing in the time. An accumulator is any variable that's used to collect information throughout the code execution, such as looping, which is why this is coming up today. We can accumulate information over the course of multiple iterations, such as in the loop, and it can take the form of augmented assignment, which we're going to talk about in a moment. We must initialize an accumulator before we can use it, because otherwise we'd have an undefined variable. An example of an accumulator would be a running totals. You could think of going shopping, and as you're adding things to your cart, then the total of the things in your cart would be accumulating. It would be getting more and more expensive as you have more and more items in your cart. So this is an example of accumulation. We'll see other examples in other loop contexts later in the course. So then if the slide will advance, there you go. Next, we're going to talk about the augmented assignment. Remember, we had talked about variable reassignment. Now we recognize variable reassignment because a variable gets assigned its initial value, and that causes it to go into the variable table, right? So variable reassignment means when the variable is already in the variable table, we may wish to update that value to be something new. That's variable reassignment. And so augmented assignment is a kind of variable reassignment, and it has a shorthand form common for tasks that are oftentimes done. So this idea of accumulating, for example, as we go through the loop, maybe we want to count how many times we've been through the loop. So we would have this idea of a counter. So each time you go through, you accumulate one more count. So the first time through, you've had 0 counts. The next time through, you have 1, 2, 3, and so on. It's often this idea of looping will make use of the accumulators, and so we can use the shorthand. But augmented assignment can also be used for other things besides in loops, but this is where we will see it first. Augmented assignment requires the rearrangement of the order of an expression. So here is just the regular notation that we have already done. This regular notation has a new x being equal to the old value of the x, which presumably is already in the variable table, plus some amount. So I'm going to use 1, but really you could increment it by any amount. The augmented assignment notation switches up the order here, and it also omits the old value of x explicitly being in the expression, but it means the same thing. So x plus equals 1 is the augmented assignment syntax, means x equals x plus 1. So for example, here we'll have the new x, then it's followed by the operation, and then it's followed by the equal sign. So you recognize augmented assignment because there is an operation and nothing after it before the equal sign, right? So x plus equals 1 is the rearranged version of the augmented assignment. So you can use augmented assignment with addition, and that's pretty much what we've been looking at so far. So the first thing you need to do is, of course, make sure you initialize your x or your variable. So here we are going to have x equals 0, and then you could do x equals x plus 1, and you could do this several times. And we see that x will get updated to have the value of 1, 2, and 3. And then if we ask what is x, Python tells us that it is 3. We can do the same thing with augmented assignment, which saves us a few keystrokes. Those computer scientists are very lazy typists. So we're going to do x equals 0 to initialize just the same, and then we'll do x plus equals 1 3 times, and we have now added 1, 2, 3 to x to get x equals 3. But augmented assignment is not limited just to doing addition. You could also use it for decrementation using subtraction. So here we could start off with an x equaling 10, and then we could subsequently subtract 1 from x each time. So 9, 8, 7, and we ask Python the value of x, and we see that it's 7. But we could have done this using the augmented assignment way, which would be x minus equals 1 3 times to give us x is 7 when we initialize it starting at 10. But why stop there? You could also use augmented assignment with multiplication. So here's the regular way to multiply a variable. We have an x being equal to 2, and then we're going to multiply it by 3 to get 18. 2 times twice multiplied by 3. And then we can do this augmented assignment. Again, we initialize x to be 2, and then we can do the times equals 3. Again, notice that the operator has been switched, and we have omitted the old value on the right-hand side in this notation. And why stop there? We could, in fact, also use this for division. So here's an example of using division. This is the regular way, x equals 49, and we could divide it by 7 2 times to get 1. And in the augmented assignment, we would use divided by equals, and we would use this 2 times so that we would be able to get the same answer. So then I just put these all together for you so that you can see the pattern. So this is what it would look like in the regular way, which has this pattern here. The new value of x equals the old value of x. Then you have some operation showing addition, but you could substitute any of these, and then you have some amount. So usually it's 1, but it could be something else. And then the new way of writing that with the augmented assignment would be the new value of x, and then your operator followed by the equal sign and the amount that you're going to change it. This will prove to be quite useful as we're doing looping. Augmented assignment is also overloaded to work with string concatenation. Now, some of these things we haven't talked about in detail, and we're going to see this more when we get to the strings, but I'm just going to give you a sense of what this is like. So you would start off with x being initialized as not having any contents yet, and then we could have the new value of x is equal to the current value of the old value of x, which is nothing, plus the character h, and then we could also add I and then the exclamation point, and we would accumulate these characters by concatenation to get the message hi. And we can also do this with augmented assignment. Notice how this looks very much like the regular addition. It's basically overloaded to work on these strings as well. So then let's get into the looping. Today we will talk about just simple basic while loops, which will introduce us to many of the syntactical features and how the loops are going to work. There are a number of different kinds of loops, and they're going to differ in how their branch guard is set up, having a Boolean expression or having while true, so your branch is just true, or how the termination is achieved, whether the branch guard becomes false, or whether a break is encountered. Break terminates the execution of that loop. So that will give us 4 categories of the loops, which we'll be talking about in the next few days. So this idea of repeated execution is brought up in the while loops. When we worked with if statements, the execution of a block or a code could execute 1 or 0 times. If we have the else, we guarantee that it will execute once. You can never execute a piece of the if block more than once, but it's also possible that if you don't have else, that the branches would execute 0 times because all the branch guards may be false. So in the idea of a while loop, these executes a block of code any number of times as long as the branch guard is satisfied. And so we have this idea of the possibility to execute multiple times, continual execution. There's no limit to how many times it will execute. If the guard is not satisfied, the associated block will not execute. So it's also possible to execute 0 times. It may execute an infinite number of times. This is called an infinite loop, and that's one of our loop categories. If the guard never stops being satisfied, and generally we don't do that, but just in case you do happen to do this by accident, you can use Control-C or Open Apple C to exit out, and you will not kill your computer. So don't worry, this is a common mistake that you may encounter. So let's take a look at the syntax. So the first thing we need to do is we need to initialize the loop. And what we mean by that is there will be a Boolean expression that has some variable in it. While I is less than 5, for example, that I, if you haven't initialized it, is in the variable table. So what's the value of I? Well, if it's not defined, it's gonna crash. So you need to do the initialization. Then you would have your statements inside of your block, and then you would counter increment so that your variable is going to change. And the idea here is that the Boolean expression is making use of the variable down here that's getting incremented. So this is how it actually steps forward, because if you don't step it forward, how will you ever know how many times you've gone through the loop, right? So that's how the mechanism works. So this just shows the flow control in the loops. So here we have a while and some Boolean expression, right? This is how it's going to be. First of all, the guard will be evaluated. Then if the value of the guard is false, then what's going to happen is that the body would be skipped, right? So you'll just jump over it and that would be the end. But if the value of the guard is true, then the body will be executed. So we're going to go top to bottom in here. After the last statement, the body control returns to the guard, and then the process begins again. So you'll see that what will happen is we will just cycle through until the branch guard becomes false. Let's take a moment to talk about the initialization of the loop. The variable that's used in the branch guard needs to be defined before it can be used, because if it's not in the variable table, and whenever Python tries to access something in the variable table that's not there, you will get an error. Setting a value of the variable before the loop is called the initialization. Failure to initialize the variable will result in an error because it is not yet defined. So let's take a look at this snippet of code here. So while I is less than 3, we'll print I, and then we'll increment I by 1. I mean, looks pretty good, right? But the problem is that something's missing here. And we see that we get this error here. I is not defined. Well, why isn't I defined? Well, the reason is because that invisible pointer, the first time it comes through, is going down in main and then counters, oh, while I is less than 3. It says, oh, let me look up I in the variable table. Oh, I hasn't been defined yet. Error. And so it will terminate your execution with an error, which is bad. And so what we need to do to fix this is we need to begin before the while loop with some initialized value. We will have I equals 0 in this case. And so now we will cycle through the loop. So while I is less than 3, so I will be equal to 0 the first time through. It will print out I. What's the value of I? It's 0. I plus equals 1 is example of augmented assignment to increment the variable I, right? So now we cross off the 0 on the variable table and increment that up to 1. We go back to the top of the loop. I being 1, is that less than 3? Yes, print I, 1, right there. I plus equals 1, increments it up to 2, back to the top. Is 2 less than 3? Yes, so we print 2. I plus equals 1, so in the variable table, we update I to be 3, back to the top. While I is less than 3, is 3 less than 3? It is not. So the branch guard is false, and therefore the execution will now terminate. Let's take a look at this example of a loop and see if we can identify the loop parts. I've taken this and I've put it in a function because oftentimes you will wish to put your loops inside functions. It's a good way to program. So this one is called count seconds. It will take in an integer and it's going to return a none type. Do you agree with that? I'm just scanning through here and I don't see any explicit return. So what does that mean? It means the return must be implicit based on the indentation of the function. And I see that there is none, so it will be returned implicitly. And when functions return implicitly, they will return none, and they will have none type. So that's how we get the signature here. And this counts from 1 up to whatever is applied for stop, which should be of type int, which we can determine from this right here. So this is the initialization of the loop. We'll begin at 1. And while I is less than stop, our branch guard, we are going to print I, Mississippi. So you might have played this game when you were a kid, when there's a thunderstorm and you want to know how far away the storm is, right? So you hear, you see the lightning first, and then you count 1 Mississippi, 2 Mississippi, until you see the thunder, and that estimates how many miles away. So that was the inspiration for this. The idea here is we're going to be printing that out, so we will count the seconds. So then, let's take a look at the sample execution of this. So if we have count seconds, this is our function call of 6, how many seconds we are going to use. Then when we do our function call, remember that it will change, it will again have flow control. So that sends our invisible pointer up to the def line of the corresponding function. The value of 6 will be sent up to our parameter stop. So this is an argument of count seconds function call, and that gets assigned to the parameter in the count seconds function. No problem that it's not called the same thing. We're simply sending a value. That's fine. And then our pointer moves here. I equals 1 to initialize our variable, while I is less than stop. Is 1 less than 6? Sure is. Print I Mississippi. So we will print 1 Mississippi. And we increment I by 1 to make it 2. Back to the top of the while loop. It's 2 less than 6. Yes. Print 2 Mississippi. I plus equals 1 brings it up to 3. And so you can start to see the pattern. Is 3 less than stop? Yes. 3 Mississippi, increment to 4, back to the top. 4 Mississippi, right? This is true. Increment that up to 5. Is 5 less than 6? Yes. Print 5 Mississippi. I plus equals 1. 6. Is 6 less than the value of stop being 6? It is not. The execution of this loop terminates and we jump outside of the loop. And that is how the execution happens. And this matches to what we see on our screen. All right, so that concludes our material for today. We will continue on with our discussion of the looping next time, when we will explore some of the other kinds of looping that exist. Thanks so much for joining us, and we look forward to seeing you in our next video.